Hi, today we will be covering every single RC equation needed for A-level physics. Let's start by considering a pair of resistors in series. Recall Kirchhoff's current law, which states that the current entering a junction, which is simply where two components meet, is equal to the current flowing out of the junction. In this case, since there are no parallel branches, we can deduce that only one current flows through both resistors. Similarly, by Kirchhoff's voltage law, we can deduce that the sum of the voltages across each resistor is equal to the EMF voltage. And so we have deduced that the total resistance is equal to the sum of the individual resistances. And here's a quick derivation of the voltage divider equation for two resistors in series. Now let's consider two resistors connected in parallel across an EMF. Kirchhoff's voltage law here tells us that the voltage across each resistor is equal to the EMF voltage. And Kirchhoff's current law tells us that the current splits at the branching to I1 and I2. From here, we can easily derive the current divider equation, which gives us an output voltage I out for a certain input voltage I in. Now let's consider a pair of capacitors in series and see how they combine. Recall the definition of capacitance as charge over voltage. To find the equivalent capacitance of the series combination, C total, let's consider Kirchhoff's current law, which tells us about the charge across both capacitors. In this case, Kirchhoff's current law tells us that the charge across each capacitor is the same. Now, let's consider a parallel combination of capacitors under an EMF voltage V. Now, to find the equivalent capacitance, C total, let's use Kirchhoff's voltage law to find out the voltage across each capacitor. In this case, Kirchhoff's voltage law tells us that the voltage across each capacitor is the same. Now let's derive expressions for the current through and voltage across a charging capacitor. Now, let's derive an expression for the voltage across a capacitor as it discharges through a resistor. Finally, let's derive a second equation for capacitance that depends on the area of overlap between two parallel plates and the distance between them.